Good morning. What we're going to do this morning is start going through a series of 3 videos on the waves and radiation, and I'm going to talk you through some of the book that you should be be reading through at the moment. The book is this one here. It's on the MyCity website. You just download it, National 5 Physics, Waves and Radiation. You should have already been going through this. I've posted up a few videos on this one, and what we're going to do is to go through the wave speed section. Now, the book talks about wave speed in 2 different ways. The first way is as you would normally talk about speed, which is speed is distance over time, and I've put that there. This is how we define speed when we were doing the dynamics in space, and this is still true. Wave speed is still always distance over time, and this triangle is always true. Okay, so speed is again distance over time, but it's also true that distance is speed times time, and time is distance over speed. Each of these should be familiar to you already because you've already done this in the dynamics and space section. And so there should be nothing new here for you. But I'm going to go through some examples and just point a few things out for you. So the first example that we've got there is a gamekeeper fires a gun at the base of a hill. A hill walker is 1,500 meters away. Here's the sound 4.5 seconds later. What's the speed of sound? So with that one, we're given that the distance is 1,500 meters. The time is 4.5 seconds, which work out the speed. So we use speed as distance over time. So it's 1,500 divided by 4.5, and that works out as 333.3 meters per second. That's roughly 600 miles an hour, 650 miles an hour. So it's very, very fast. Interestingly, the speed of sound varies in different materials and different conditions. So if you look at air at 0 degrees, the speed is 331 in air, but at 20 degrees it's 343 actually, goes faster. And you guys being future sea captains and lieutenants and everything will be pleased to know that in seawater, the speed of sound is 1,533, so it's much faster in the sea than it is in air. And as you can see in metals, it's even faster still. And we're going to apply this to sonar later on. So the practice problems are as follows. During a physics experiment, a pupil finds it takes a sound wave that amount of time to travel 1.5 meters. What is the speed of sound? So the speed is just distance over time again, and if you plug the numbers in, you get 300 meters per second. The next one, if the time taken for light to travel 750 million meters is 2.5 seconds, what is the speed of light? You just plug the numbers in, so 750 million is that. Divided by 2.5 is that, and you get 300 million meters per second. And that is 3 times 10 to the power of 8 meters per second. The speed of sound, the speed of light, beg your pardon, is the fastest thing that we know of in the universe. As far as we can tell, nothing goes faster than the speed of light. We've actually got a special symbol for it, which is c. So c, which comes from the Latin word celerus, which means rapidity or speed, is the symbol for the speed of light. You could have put in 750 times 10 to the 6 divided by 2.5 on your calculator if you wish. Number 3, if the speed of sound in air is 340, how long will it take? So this one is a time question. So time is distance over speed. So the distance is 5.1 kilometers, and that won't work. You need to change it into meters. So it's 5,100 meters divided by the speed, which is 240 meters per second, so you get 15 seconds. Number 4, if the speed of sound in water is 1,500 meters per second, how long? Again, a time. Will it take sound and water to travel 1.5 kilometers? So again, time is distance over speed. And again, you can't put 1.5 kilometers in because the speed is in meters per second. So you change it to 1,500 meters. Divide that by 1,500 meters per second, you get 1 second. It only takes 1 second to go 1.5 kilometers. So the application to that would be sonar. And then the last one is number 5. When tourists near Edinburgh Castle watch the 1 o'clock gun going off, they see the puff of smoke 5 seconds before they hear the bang. So if the speed of sound is 340, how far away is the castle? So the distance is speed times time again. So this one is the last of the equations, the other equation. So for this one, you take 340 and you multiply that by 5, and you get 1,700 meters or 1.7 kilometers. The reason for that, of course, is that the speed of light is so much larger than the speed of sound that they see the gun going off instantly. So you can just say that's time 0. But then it takes sound, which travels very fast to us, but to light it doesn't. It then just begins its journey, and 5 seconds later it reaches their ears. So that's how that works. So that's all I have to say to you. Next one up is the wave equation, V equals F lambda. So we'll do that in the next video. Thank you very much.